Alright, what I'm trying to show you here is a basic testing setup for the ROCKETuC firmware, as well as how you can use ROCKETuC together with the Processing IDE. And well, let's have a look what we have here. First, you see that MSP 430 Launchpad. It uses a 2553 MSP processor, and it is connected through the USB to serial converter to my PC. And the firmware enables you to easily access all the functionality you basically have on such an microcontroller, like digital outputs, digital inputs, pulse width modulation and stuff like that. You also have analog readings. Yeah, well, actually what I'm going to show you is how you can use digital outputs, for example, to light some LEDs, how you can use digital input to read the states, for example, for some buttons. I use different buttons. One is the built-in button from the Launchpad. One on the Launchpad comes with a pull-down resistor. The other buttons I connected here. One uses the internal pull-up resistor of the Launchpad, and the other one uses the internal pull-down resistor. Then we have a potentiometer, and that one is used to show you how analog readings can be done. Well, and here on that side we have a little servo, and that servo we are going to drive through a PWM, which is also possible through the ROCKETuC firmware. Alright, let's have a look at the processing side. What you see on the screen there is a freshly started up Processing IDE. And if you go to the example section of that Processing IDE, you can navigate down until you see contributed libraries, and there you'll find a processing rocket library. And under that you'll see all the examples provided with the processing library. Alright, we'll have first a look at a very simple example which is called Blinky. It does nothing more but blink the built-in LEDs of the Launchpad. As you can see, it takes not much code. You have basically a setup section, and then you have all the looping stuff, which is the blinking of the LEDs in the draw section. If we fire up that one and have a look at the Launchpad, we will see that those built-in LEDs are blinking, alternating. So that's very basic, very simple, but there is more you can do. Actually, there is another example which is called Simple GUI, and that example Simple GUI will provide you a very basic GUI to check out all the features the processing firmware includes. So if I start up that GUI, I'll be presented with a screen which shows every input or pin actually of the Launchpad, and it shows which configuration it actually has, and you're able to change that configuration. So for each pin you have DO, which stands for digital output, you have IF, which stands for input floating, you have IU, which stands for input with pull-up resistor enabled, and ID is for input with pull-down resistor enabled, AR stands for analog read, and PW stands for PWM. So actually, let's see what we can do if we set P10 to digital output. Then the state section changes, and it shows the current state of that output pin, which is low. And if I click on that, it goes to high. It indicates that with the green light here. And you also see, if you go to the Launchpad, that the light, the built-in light on pin 10 lighted up. And if I go back to the GUI and toggle that one off, and go back to the Launchpad, you see it toggled off there too. So that's pretty simple actually, and you can see how it works. Now let's do something a little bit more interesting. We have that built-in button, which is on P1.3, and as told before, that one is equipped with a pull-up resistor, and thus it lights up in green, and if you press that button, it will actually go to low, indicating the button is pressed. Alright, we can do that some more. Good. So then we have another LED on that pin 2.5, and that one is low by default, and we can switch it on as well. Alright. And we can see the blue LED lighted up as well. So what's next? What can I show you? On that pin 1.5 there is the potentiometer, and the potentiometer can be read by switching the mode of that pin to analog read, and as soon as we switch the mode we'll see how much voltage is measured on that pin actually. And if I go and turn that potentiometer a little, I can turn the voltage up and down. See, I just use that potentiometer to increase or decrease the voltage. Alright, then as I told you before, we have those other buttons which use the internal pull-ups or pull-downs. They are connected actually to pins 2.3 and pins 2.4, and you see it is configured by default as input floating, and that's exactly what it does. It is floating because it does not have a external pull-up or pull-down resistor. But if we go and set it up correctly, like pull-down, it is actually low because it is pulled down now by the internal pull-down resistor, and if we press that button it immediately goes to high. And as you see, the other one, 2.4, also goes to high every now and then. That's because it is also configured wrong. It has to be input with pull-down, and you see now it steadily goes to high the moment I enable the internal pull-up. Alright. So if I press the other button, it goes down, and if I press that one, it goes up. So actually, those buttons are the buttons I'm pressing right now. And yeah, that's what you can basically do with that simple GUI. Then we have one more to go. That's PWM. There are a few ports where you can use hardware PWM, and one of those ports is port 1.6, and if I switch it to PWM, that's the other building, the green one actually, I have the period of the PWM in the status section, and I have the duty cycle in percentage. And with those fields, the greens and the reds, I can change the period and the duty cycle. The big green field increases by hundreds, and the smaller one by tens, by thousands, and that one by tens, and that decreases the same thing. So let's see what happens if we a little bit go down with the duty cycle and actually have a look at the green LED. I'm still switching down. Now I'm at 0% for the duty cycle, and the green LED is off. And if I go to 10%, it goes on a little bit. I go to 20%, it goes on more. Like 30%, it's a little bit more. 40, 50, 60, and so on. So, well, that's pretty smooth, I think. But we also can use that PWM for controlling a servo. And I connected the servo to pin 2.1, and I use PWM for that as well. As you can see, the servo now just reacted and makes strange noises. That's because the pulse length is not set correctly. That's in microseconds, and you need to have a pulse length about 20,000 or 22,000 microseconds for a servo. So we'll just adjust to that. Let's take 22,000, that's good. And then you can operate the position of this servo if you use a duty cycle in between 4 and about 40%. So let's see what happens if I alter the duty cycle. It's now 5%, it's now 6%, 7, 8, 9, 10, 11, 12, 13, and 14. And that's it. You can switch it back. Yeah, now let's what you can do with that PWM2. So yeah, actually give it a try and have a look at it, and yeah, give us feedback if you like it or not, or what you miss, and thank you for listening.